Hi everyone, in this session we are talking about Centroid versus full atom representation of a pose. So sometimes you want to do some calculation, especially scoring on your pose, and full atom representation, which like the name suggests all atoms are there, is kind of heavy to calculate. So Rosetta has some other thing called centroid representation, in which the side chains are replaced with a virtual atom. That kind of implies the properties, but not all atoms exist there. And now we're going to code and learn how we can switch centroid to full atom or vice versa, and how they really look different. You remember from last session, I can import a pose from RCSP. I do go with the same thing. So we have the pose. If I go and show it to you, we have the PDB file here. I download it. You see that all the atoms are present here. So it is the beginning of the chain, and the side chains are present here. I can use a mover to convert this full atom pose to a centroid pose. So let's say my mover equals, the name of this mover is switch residue type set mover, and then I should pass centroid to it, and then apply this mover to my pose. Okay, this is done, and here if I check it, I can say my pose dot is centroid. It should return true. There's also another one called my dot is full atom, and here it should return false because we switched it to centroid. And now if I, for example, look at the number of atoms, I pose that total atoms, you see that compared to last time we had 4994, now we have almost half. So some atoms which are side chains are removed. But to really see what happens, I want to dump this pose to a file and then show it in Panel. So the file is dumped. It should be here. It is here. Now the new file is shown in blue, but you don't see the difference. I go close to the first one again, just orient it. And here you see that if I hide this one, instead of this side chain, we just have one atom here, and it's the same for all other atoms. Okay, this was easy. You can also, if you have a centroid pose right now, you can also use the same mover but passing full atom to it. So I just copy this and I pass full atom. It changes. Okay, yeah, it was underlined, not a dash. And you pass full atom to it, and now your pose is a full atom. So if I check my pose dot full, my pose dot is full atom, it returns true. And if I check the number of atoms to see, like I don't want to put just hydrogen instead of that virtual atom. I want all atoms to be there. So if I check the number of total atoms here, you see that this is as original. So it knows what it's doing. It doesn't remove that data. Not all those virtual atoms are the same. Okay, now we go to answer the question from the last session. I have the code ready here, just showing you. First get the pose. You should only know the ID and you can easily search it in PDB. You run it, it gets the pose for BSA, and then I get the number of cysteines in the sequence. So I get the sequence with pose.sequence, and then the number of cysteines is the sum of C characters in that sequence, because the output here is a string. And then I report that this sequence has this number of cysteines in itself. And then I found this annotation, cis disulfide, in annotated sequence. So I get the annotated sequence and save the count of this phrase in that string by .count. And then I report it, and then I get the percentages by dividing them. So it has 70 cysteines, 68 of them form a disulfide bond. Therefore, 97% of cysteines have disulfide bonds. I hope you have enjoyed this video and see you next session.